Hi everybody, in this video we're going to see how to integrate simple functions. By the end of this lesson, you should be able to integrate any function of the form a times x to the power of n, where a is a constant and n could be a fraction or an integer. Yeah? You should also be able to integrate exponential functions and the trigonometric functions and a special case as shown here, and evaluate definite integrals. That is when you have to integrate within a given limit. Yeah. So what is integration? Integration is simply a reverse process of differentiation. So if we have a differential function dy by dx is equal to a times x to the power of n, then y must have been a x to the power of n plus 1 over n plus 1, right? So you can work it out as I have shown here. Very good. So the power of x has increased by 1 and then divided by the new power of x. So that if we were to differentiate y, it would give dy by dx is equal to n plus 1 times a x to the power of n plus 1 minus 1 over n plus 1, which is nothing but a times x to the power of n. So integration is simply the reverse process of differentiation. Okay, so when we differentiate constant terms, they disappear. Therefore, when we integrate, we reverse the process and add a constant. So if y is equal to integral of a x to the power of n dx, then y is equal to a x to the power of n plus 1 over n plus 1 plus a constant of integration, which we use c to denote the constant of integration. So if we have a function ax to the power of n, and if we integrate the function, we increase the power by n plus 1, and in the denominator you have a new power, you have the new power n plus 1 plus the constant of integration. And now if we differentiate this function, we decrease the power from n plus 1 to n, and we multiply with the old power n plus 1. So we cancel the n plus 1, and you get the function ax to the power of n. This is what I mean by differentiation and integration are reverse process of each other. Yeah. So the constant c is introduced because a constant may have been present before differentiation was performed on this function. Yeah, and is called the constant of integration. So it's very important that you add a constant of integration after you integrate a function. So there is a special case. If dy by dx is equal to 1 over x, then the differentiation of this function, integration of this function is ln x plus c. Okay, so please do not rearrange this as x to the power of minus 1, because this is wrong. It's an invalid solution. Okay, now I think you should try these couple of problems. Very good. So let me show you an example of integrating a function of the form ax to the power of n. So here you can take the constant 4 over n9 out of the integral and then use the formula to integrate it. Yeah, so 4 over 9 times t, 3 plus 1 over 3 plus 1 plus c, and there you go. Simplify further wherever you can, and there you go. So this is your final answer for the integral of this function. Okay. Now if you have an exponential function, for example, dy by dx is equal to ae to the power of kx, you take, before integration, please take the constant out. Makes it easy for you, yeah? And then integrate the function. So here, there is an example for you. So you can rearrange this as 2 over 3 times 1 over e to the power of 4t dt. You can write this in the numerator, e to the power of minus 4t dt, and then integrate this function using this formula. So multiply by the coefficient of t, which is minus 4, and divide the whole exponential function by minus 4, as you have here. Yeah, there you go. So now if you differentiate this function, you should get this function back. Why don't you try that? Excellent, very good. So let's see how to integrate sine and a cos function. Yeah. So if you have dy by dx is equal to a sine kx, then y is equal to a sine kx dx is equal to minus a times, just take the coefficient of x in the denominator, and then you have minus a over k cos kx plus c. Do not forget the constant of integration. Similarly, if we have dy by dx is equal to a cos kx, then the integral of a cos kx will be a over k sine kx plus c. So now if you differentiate this function, you should get this function. Similarly, if you try to differentiate this function, you should get this function. So why don't you try this out? Very good. So let's take an example how to integrate a sine function. Yeah, let's use this formula or the general rule to integrate this function. So you take the constant out, phi out of the integral, write it in this form, and then simply use that rule to integrate a sine function. So multiply by the coefficient of theta. So you're integrating here with respect to theta. So it becomes 2 times phi sine 2 theta over 2. There you go. So why don't you differentiate this function and see whether you get the same function? Very good. So let's try the cosine integration of this cosine function. So here the coefficient of x is 2. So you're going to multiply by the coefficient of cos 2x, 3, and divide by the coefficient of x, 2. So 3 over 2 sine of 2x. So let's see that how we do it here. So take 3 out, 3 is a constant. Now integrate it using this rule. There you go, multiply by 2 and divide by 2. Now why don't you try this? Differentiate this to see whether you get the same function. Very good. Now if you have something like this, like a function like this, yeah, 2 root of x minus 3 over e to the power of 3x, then you can integrate it term by term, just like we did in differentiation. Yeah, so integrate 2 root x first, and then the second term minus 3 to the over e to the power of 3x. Yeah, so let's do that. So let's write it in this form first so that it's easy for us to integrate, then integrate term by term. So you can integrate first 2x to the power of half, then integrate minus 3e to the power of minus 3x. Then write the constant of integration. So remember here, only one constant of integration is added, even though there are 2 terms here. Yeah, because it's a constant of integration. It is a constant. Yeah. So similarly, if you have something like this, you have a common denominator here. So you can divide the common denominator. Yeah, each term in the numerator is divided by the single term in the common denominator. Yeah, and then you will have something like this, and then you can integrate term by term. So integrate the first term here, and then the second term here. Please try that. Very good. Very cool. So please do not forget to write the constant of integration. You may lose 1 mark there. Okay. So now let's see how to evaluate different integrals. Yeah. So different integrals are those integrals in which limits are applied. So usually if an expression is written as this, so the upper limit is b here and the lower limit is a. So you're integrating from a to b. Yeah. So let's do that. The integral constant c will cancel here because c minus c gets cancelled, as we will see now with an example here. Yeah. Okay, let's take an example to see how this works. So here we have a common denominator. So simply divide this with a common denominator and then you have 3 different terms, just like this. Yeah, there you go. And then you can apply the limits. There you go. So here you will cancel the limits. Yeah. Okay, now let me just give a summary of all the rules we have just seen. Yeah. Very good. So that's all for now. Please try to solve these problems. Thank you very much.